Hello and welcome to Coderific. In this video, we are going to see some of the evaluation metrics from Sklearn library in Python. These metrics are very helpful in analyzing a classification model. Most important classification evaluation metrics are AUC-ROC, confusion matrix, and classification report that we are going to see in this video how we can use them writing our code. Before I take you to my Spyder Python editor, let me give you a quick introduction of these basics evaluation metrics, and one of the most important evaluation metric is AUC-ROC. AUC stands for area under the curve and ROC stands for receiver operating characteristics. It is one of the most important evaluation metrics for analyzing the performance of any classification model. It is also written as AUROC, which stands for area under the receiver operating characteristics. So in this slide, I have pasted an example of how AUC-ROC curve looks like. It is basically computed based on false positive and true positive rates. As you can see, the false positive rate is listed on x-axis while the true positive rate is listed on y-axis. ROC is a probability curve and AUC represents the degree of separability. It tells how much the model is capable of distinguishing between classes. Higher the AUC, the better the model is, or it means that the model is predicting 0 classes as 0 and 1 classes as 1. So as you can see that the black dotted line represents the threshold that is built between the minimum and the maximum probability, which is between 0 and 1. For example, in the case of MNIST images, there are 10 classes starting from 0 to 9. Each class is represented using different color scheme, and you can see that all of the classes have almost similar ROC curve. So these lines represent the area which is displayed here statistically, and the area under ROC is represented as AUC. For example, if AUC is 0.7, it means that there is 70% chance that the model will be able to distinguish between positive class and the negative class. But in this case, as you can see that the highest AUC is 0.99. So it means that there are 99% chances mostly that this model distinguish between the classes. Another evaluation metric that we will see how we can write a code for it is confusion matrix. Confusion matrix is one of the most important metrics to evaluate the accuracy of a classification model. So for example, in this picture you will see that the x-axis represents the actual classes and the y-axis represents the predicted classes by the trained model. So in this image you can see that the middle line represents how many times the trained model predicted 0 for 0 class or predicted 1 for class 1. So as you can see that most of the cases the model has predicted correct values for each of the input class. But in the worst scenario, you can see that 10 times model predicted 9 for input class 4. So confusion matrix is very important to see such insights obtained by the trained model. Another most important classification evaluation metric is classification report. It is a metric from the same Sklearn library. If you want to evaluate the performance of classification model only theoretically, you can use this function classification report of Sklearn library that will build a text report for you showing the main classification metrics, which are precision, recall, F1 score, and support. So now we know how these classification metrics display the data. Let's start programming. As you can see, I am back to my Spyder Python editor, and I have already imported the important libraries that I'm going to use in this program. As I told you before that what Sklearn metrics I am going to use in this program are classification report, ROC underscore curve, AUC, and confusion matrix. I have imported these metrics from Sklearn.metrix, and to visualize graph I'm going to use matplot.pyplot library. So why I am using these evaluation metrics is to analyze the classification model that I trained in my previous video. I will add a link to this video in my description box. You can see that I have already imported the user-defined functions that I created in my previous video. One of that user-defined function is mean squared error, and mean squared error can also be used as an evaluation metric. Another user-defined function that I have included for my previous video generate one hot encoded labels. I trained my model on these hot encoded labels, and the model I am going to use is the same from that video, but the difference here is that I have enclosed this model inside a user-defined function. I have named this function as load underscore model underscore. This function includes layers starting from input layer, definition of model that takes input. Next, to compile the model using the same parameters of loss and optimizer, and finally using this compile model I am going to load the weights from the trained model from my previous video, and finally this function returns the loaded weights of model. Next, I am going to load MNIST dataset so that I have my test subset to evaluate the performance of trained model. Next, I am going to convert the unsigned integer format of MNIST images into float. I am going to do this only for the test dataset. Next, I am going to generate one hot encoded labels over labels of y-test subset. Using the textual statistics, I am going to first evaluate the trained model based on very basic evaluation metrics, one of which is model.evaluate, and using this function we are going to see accuracy of trained model. But before we evaluate the model, first we need to call the functions so that we have the uploaded trained model. So this is the model that I have generated above here, that includes all of the layers starting from input layer to the compilation. And using this compile model, I have loaded the weights of trained model, the name of my trained model, which is in the format of HTF5. I have passed this name to this function. Next, using this model, I am going to evaluate its performance on X-test and Y-test datasets. Next, I am going to predict labels of test images. Remember that test labels are in the format of one hot encoded labels, and the trained model also predicts the labels in format of one hot encoded labels. And to perform a root mean squared error on the predicted and the ground truth labels, first I need to decode these labels from one hot encoded vector to a scalar value for each class. And to compute the mean squared error over predicted labels and ground truth labels, I have called this function and I'm going to print the information. So in this print format, I am going to see that for ground truth element at position 0, the model has predicted what label. So these are one of the most basic evaluation methods that we can use to analyze the performance of our trained classification model. Let's run the code written so far. In my IPython console, you can see that my model has finished testing, and the test accuracy I obtained on this trained model is 98.5%, and the RMSE error is 0.52. And we can see that for class 7 it has predicted the correct class, which is 7. Next, I am going to write a code for visualizing the AUC-ROC curve for each class, and to do that I am going to generate a user-defined function, and I have named this function plot underscore ROC underscore curve underscore, and this function will take 3 parameters. The first parameter I want to pass is the name of file. This name of file will be used to save the plot. Second parameter, I am going to pass the predicted labels, and the last parameter I have passed ground truth labels. So in this function I will be using one hot encoded label format. I have passed y-test because it is already in the format of one hot encoded labels, but here I have passed the predicted labels because in this function I will convert them into one hot encoded labels. But there is a question why I am not using y underscore predict labels, because if I click on the values of this variable, you can see that the predicted model has generated probability for each class, including the highest probability of the actual class that might belong to the input. I don't want to use these probabilities. That's why first I converted y underscore underscore predict into scalar values so that it contains actual class for each value. That's why I have passed these scalar values of each class labels, and inside the function I will convert them into one hot encoded. So basically I have discarded the probabilities and I am going to replace them with zeros. Now I am going to define this function. First parameter of is the name of file that I will use to save the plot, and for the rest of the parameters I have used the same variable names. First I have defined total number of classes. I want to preprocess the predicted labels that are in the format of scalars. I want to convert them into one hot encoded labels. Method to convert the scalar values of classes into one hot encoded labels is using label underscore binarize function. I have imported this function from Sklearn.preprocessing library. This method is the quickest method to generate one hot encoded labels from scalar values of classes. I have passed is the total number of classes, and on this total number of classes I have created a range that will start from 0 to 9. Next I am going to create ROC curve. As I told you before in the slides that this curve is computed based on false positive and true positive rate. Therefore first we need to compute false positive and true positive rates. First I have created false positive, true positive, and ROC underscore AUC empty dictionaries so that I can append new generated data over each class. I'm going to run a loop over range of total number of classes. So here I have used ROC underscore curve function extracted from Sklearn.Metrix, and this function takes two parameters, the predicted labels and the ground truth labels. So from this indexing I am going to extract class by class information, and if I click on the y-test dataset you can see that each column represents one class. For example, this column represents 0 class, this column represents the 1 class, and the last column represent the class 9. So in this line I am going to generate ROC curve based on each class. The first value returned from ROC curve is false positive rate, second value is the true positive rate, and the third value I am going to discard. Now that the dictionaries FPR and TPR contain false positive and true positive rates for each class, next I am going to simply generate AUC on these false positive and true positive information of each class, and I'm going to assign AUC information to ROC underscore AUC dictionary. So I have done computing the ROC curve based on false positive and true positive rates over each class. Next I am going to plot them. First I have defined the line width. This line width will be used to define every line of ROC curve, and to generate the canvas of my plot I have generated object of figure using PLT. Because I have 10 classes, next I have defined color for each class so that my every class is represented using different color inside the plot. You can keep the same settings of colors. If you want, you can also use any of the colors you like. Next I am going to run a loop over total number of classes with respect to each color, and to plot the false positive and true positive I am going to use plt.plot function. The first parameter represents the data that will be plotted on x-axis, and on x-axis I have used false positive. The next parameter I have passed is true positive rate, which will be represented on y-axis, and for each line on the plot I have used the color from for loop iterator, and each line of the ROC curve will use the same width that I have defined here, which is 2. The next parameter I am going to define is label for each line. So I should have a unique label for each class, and to do that I am going to use a formatted input. So here I want to print something like ROC curve of class and area. So in this parenthesis I am going to print the number of class, simply taking from the iterator I, and for this parenthesis the output will be taken from ROC underscore AUC indexing I. Now I am outside the loop. Next I am going to define the plot. So in the first line of plotting I have created a threshold that will use the minimum and the maximum probability, and for this case I have used the threshold starting from 0 to 1, and this will be represented as a dotted line in color black. And I have defined the x limit and the y limit. X label, which is false positive rate, and the y label, which is true positive rate. And the title is because this graph will represent receiver operating characteristics of multi-class, so I have kept the same title. And the position of legend I have used is lower right corner of the plot, and the size of the plot, so that it is not spread all over the plot, I have reduced it to 8. To save the plot, I am going to use savefig function of plot, in which the first parameter is the name of function, and the format of this file will be png. It is important to specify this, and to keep the highest resolution so that the plot is not blurry, I have used TPI 600. I am going to show this plot. So this function will return nothing. I'm going to call this function. You can see that my plot has been generated, and you can see that the highest AUC is 0.99, and the threshold I have kept is between 0 and 1. And as you can see in my files explorer, the plot is saved, and if I open this image, you will see that my image in the format of PNG has perfect resolution, and I don't see any blur tag in this plot. Next, I am going to write a code to generate confusion matrix, and I am going to follow the same pattern by defining a user defined function. And the name I have chosen is print underscore confusion underscore matrix. The name of image in which the plot will be saved is confusion underscore matrix in the format of PNG. Here, if you see the difference, that I have passed the parameters that are in the format of scalar values, keeping the value of every class as it is. So basically, confusion matrix does not need one hot encoded labels. Next, I am going to define this function. So here I am going to use a different library to plot the confusion matrix, and that library is Seaborn, that I have imported using the alias sn. So first, using the reset underscore originate function of Seaborn, I have created a canvas basically. Next, I have declared the font size using the set function, and here I have used font scale 1. Next, I have defined the background of my Seaborn plot as white grid using the set underscore style function. So basically here I want to use the prefix class in front of every class digit, and to do that I have used again the formatted input. First, I have run a loop over unique gt underscore test in case if we don't know the exact names of classes. So I have simply taken the unique inside my ground truth test, and each class name after being iterated through I will be concatenated with prefix class, and this way I have generated new class names. So I have not used any space between the prefix class and the name of class. Next, I am going to call confusion matrix function extracted from sklearn.matrix, and this function takes two parameters. The first parameter is ground truth test, and the second parameter is predicted labels, and the information generated from this confusion matrix will be assigned to variable confirm. And to print these information generated by confusion underscore matrix function, the best way is to convert this information into data frame. So I have called data frame function, which will take this confusion matrix information, and the index will be used the column names that I have generated here. Next, to generate confusion matrix, I am going to use heatmap function of Seaborn that takes data frame information as first parameter, and the format of color I have used is a range of blues, and I have kept the annotations on so that I can see the values over actual and predicted classes as I showed you in my initial slides. And this parameter is very important. If you don't use this format, the total number of predictions that are above 1000 or 100 will be used in scientific annotations. If you want 1000 to be displayed as it is, you need to use format parameter and assign value g. So the plot generated from Seaborn will be assigned to variable x, and using this x I am going to define x label and y labels. So x label will be my actual values that are ground truth labels, and the predicted labels will be printed on y labels. And to save the plot, first I need to get the figure from Seaborn using the same object AX, and I have assigned this figure into another variable which is SNS underscore plot, and the size of the plot I have specified in inches, which is 10 width and 6 is height. Next I'm going to save this figure. So again, this function is only printing the plot and returns nothing. Next I'm going to call it. You can see in my plots explorer that the confusion matrix has been generated, and if you notice that the names of classes are not just T0 but are concatenated with the prefix class without space in between. And in my files it is also saved as PNG. And the last function that we are going to see is the classification report, which is a textual description of basic evaluation metrics used to analyze the model performance based on actual labels and the predicted labels. And to do that, I'm going to call classification underscore report function that I have extracted from sklearn.metrix library. And same to confusion matrix, this function will also take the scalar formats of actual labels and the predicted labels. And the report generated by classification report will be assigned to simulation underscore report variable. Finally, I am going to print this information using simply the print command. I'm going to run this. You can see that for every class I have precision, recall, F1 score, and support statistical information, and I can also see the accuracy and some other information that can be useful in further processing. This is it for this video. Thank you for watching. I hope you find it helpful. If you did, do like and share. Also subscribe the channel and hit the bell icon so that you get notified whenever I upload a new video. If you have any suggestions, leave them in comments section. I will do consider it. Thank you.